thank you for coming. I'm going to introduce Erin Shellman now, who is also an AES committee member and who provided us with the topic and speaker for this meeting tonight.
Yay. You already met me, so I'll keep it brief. I'm super excited to introduce Peterson, in part because I've been spending a lot of money buying his kits. And if you haven't seen them, or if you didn't see them over by the cookies, I've got some examples of a little bit of what he'll show you tonight. But if you want to see them up close, they're out there. I won't spend much more time. I think he's going to tell you a lot about what he does, and excited to hear it.
All right, great start. Thank you for your patience. So it's really an honor to be here. I really appreciate the invite, Erin and Dan and everyone for having me. And it's phenomenal to see so many people introducing themselves with test equipment in the background or even a test result plot. So it's very exciting because this is the kind of thing that I love to talk about. This topic tonight especially is something that I feel kind of compelled to share with people, but it's not the kind of thing that really, makes me popular at a dinner party. So it's cool to have a group of people who have actually willingly shown up to hear about test equipment. So that's phenomenal. A bit of context. I run a company called DIY Recording Equipment. We've been around for about 13 years, and we make DIY kits to build your own preamps, compressors, EQs. It started when I was a musician, drummer, recording engineer, and as many of you have experienced, in trying to get my first studio together, not even studio, just set up to be able to record a couple channels. I quickly ran into the issue of cost, and I suppose I'm kind of wired to think there's got to be a better way. There's got to be a way to record a band without spending what the market seems to want me to spend. So I did a lot of research and Googling. This was about 2007. And I stumbled on this forum, groupdiy.com, which some of you might be familiar with. It's still around. And I found that there were people building their own audio equipment for pennies on the dollar, building their own U87, their own U87 condenser microphone, their own 1073 microphone preamp. And so that just blew my mind. The only problem was I had no technical experience. I was a drummer with a philosophy degree. So I immersed myself in that as a hobby for several years, and built myself a little recording rig. And on the side, I thought, well, I've kind of amassed enough knowledge to make my own little kit. And there seemed to be a gap in the market for really basic beginner stuff. You had, mic pads like Rick's working on right now. And then you had, things with hundreds of parts. And back then there weren't really people doing what I'm doing, which is step-by-step instructions and email support and that kind of thing. You were really on your own for the most part. So I released a reamplifier box, just a little passive box, basically a transformer with a couple jacks. And oh good, we're gonna get video of Rick making mic pads. And I put that on eBay. And so that's the beginning of what now is my company. We now do much more complex things than a reamp box. We still sell that reamp box, but we also sell up to a 2-channel rack mount bus compressor, with couple hundred parts. And so how I got from there to here, one of the key tools that allowed me to do that is what I'm going to talk about tonight. So once we started to move beyond really basic stuff, in fact, once we started designing the color format, which I think might be making its way around the room there, but I've also got some here to show you. But the color format is something I created in 2014. And the idea was based on a epiphany I had when building gear, that inside a big rack mount piece of gear, let's say an 1176, which I think probably a lot of people are familiar with. It's a compressor. I think it's 3 rack units, maybe 2, and it goes for a couple $1,000s. Inside that thing, there's really a very small amount of circuitry that's contributing the vast majority of the tone to that unit. And my thought was, well, wouldn't it be cool if we could just take that circuitry and put it on a small interchangeable card? So I've got one right here. This is not an 1176, it's a different circuit. But this was what came out of that, was I thought, oh, it would be so cool if we could take a bunch of those circuits from different pieces of gear with different tonal characters, and then be able to plug them into different things and bypass them and control how much signal we send to them. So that it was the birth of the color format, which I can show you another example of here. So the color format is made up of colors, which I just showed you, which are just, for the most part, circuits lifted out of vintage gear and then adapted to a little card like that. And then, is the blurring thing gonna, I think I can unblur my video here. I'm just going to go ahead and share my screen, then I can show you screen share. Okay, and then hide this stuff. Okay, so here's the, I'll come back to that. So this is the color format. So the colors you just saw, they're those little cards. And then the cards plug into things called palettes. And we make a few of them. There's a mic preamp, which I'll open up here. This mic preamp has a slot, which is in black here, for you to put in a color. So it's like a very transparent, clean, low noise mic preamp. And then you can add in one of these circuits to engage or disengage. And then we have a line level one with 3 colors. And then we have this rack mount one, which is a stereo kind of mic and line level processor. So I go into depth on this not just to tell you about my company, but also because this is what I'm going to be using tonight to demonstrate the software. But once we started designing these things, we really hit a wall where we realized, we need some real test equipment here. We need to know exactly what the total harmonic distortion and noise and frequency response of these things are. First of all, for measuring the old gear that we wanted to replicate to make sure we were headed in the right direction. And then to test the specs of what we were doing. So then that began kind of a very similar process to what happened when I got into recording, which was, oh my God, this stuff costs tens of thousands of dollars. A nice test setup costs as much as a car. And so I went looking for, is there a better, cheaper way to do this? I won't say better, but cheaper way. And That honestly took me a few years. I almost bought some really expensive stuff. The technology has, and especially freeware software, has gotten a lot better since that time, about 10 years ago. But it also took me a bit to really believe the truth, which is that with a really nice interface and some free software, we could do basically all of the audio measurements I needed for designing analog gear for free, assuming that the interface is a sunk cost. So that's what I'm going to demonstrate today. I'm not going to go too deep into tutorial stuff because I know you don't all have computers in front of you. So I'm just going to demonstrate kind of how I would do a few different measurements, and hopefully that will inspire you to download this software and try it out on some of your own equipment. I don't think, given the makeup of the group and what people said about why they're here, that I need to motivate you to do that. I think, well, if you're here, this sounded interesting to you. But I will just say that part of my journey as a non-electrical engineer, as basically a musician who's learning as he goes in order to make gear that sounds good, my journey with measuring gear has been one of constant surprise, mostly about trust. It's a constant. Often what happens is I have a hunch based on my ears, and I think that doesn't seem right. That's not what I've read about on the forums or on the marketing, or it's just not the way people talk about this unit. People say, for instance, that this preamp is really colorful. It almost sounds like if you read certain forums, you would think it was a distortion box. But to my ear, it's very clean. And then having the measurements to either confirm or disprove my hunch has been just a great way to get to know my tools and also my ears, and understand kind of like how my hunches from my ears correspond to the measurable reality. So it's something I really, if you're into gear, if you're into recording, it's something I encourage you to just start playing with and see what surprises come up, because I think they will. So before I get into any, before I start opening software, I'd like to, I guess, take a little pause for questions about the color format or anything I just spoke about. And Bob Smith just gave a good note on in the chat that an API X555, or an AP, sorry, not API, an audio precision 555 is 35K. And so that would be the non-free version of what we're doing tonight.
So any questions for anybody? Anybody? Mute yourself. Okay.
Moving on. Great. Okay. Okay. So what I've just opened up is called Room EQ Wizard, or REW. It's a free software that, as the name suggests, is intended primarily for measuring the acoustics of your room. It's a phenomenal tool for that. But I think a lot of people don't know, and this is where I get into getting really excited about spreading the word. People don't know that you can use this to measure equipment as well. So let me show you how to do that. First
To be
off,
clear, this is a sorry, this is a free download from someplace.
Yes, this is a free
Correct?
software. If you just look up Room EQ Wizard, it's donationware. You can donate if you feel motivated to. And it keeps getting updated, and it keeps getting better and better. So I've got all set up here. I'm using an RME 2-channel interface for this demonstration. And And so the first thing I want to show you is frequency response. So this is just under the measure tab here. I'm going to ignore that. Now we don't care so much about SPL when we're dealing with gear. So I'm just plugging the output, one output of my interface into another input, and I just want to show you, what a totally flat sweep would look like. So this is my RME ADI2. I'm running these samples at 96 kilohertz. I'm just doing a kind of example sweep here. The sweep length is an important setting to take a look at if you start playing around with this. In general, you want to go longer, you'll get better resolution. I'm just going to do short for fairly short for this demonstration. And I'm just going to do a 20 hertz to 20 kilohertz sweep. So this is where, if you're doing this on your room, as probably a lot of you have done, you get something usually pretty ugly with a lot of mountains and valleys here. But this being a high quality audio interface, we just have this straight line here. We have a dotted line down here for phase. So that, excuse me, not super interesting, but cool to at least know my interface is flat. The distortion tab, though, is really fun. So if you're not accustomed to looking at this, it's not so intuitive. So what we're seeing on top is the fundamental, it's just the sweep. So we're seeing that was flat. And then down here we have different lines for noise and then for different harmonics. So you can actually click on a different frequency. So you can see at this blue number near the bottom here what frequency exactly I'm selecting, and it shows you the harmonic content, or it shows you the harmonics for each frequency and what percentage they are. Just incredible freeware. And this is really where, if you're checking out different gear, this is where you're going to see a lot of the character represented, is not just how much does it distort, but at which frequencies. A lot of the tone of these kind of classic analog circuits, you're going to see the harmonics distributed differently throughout the spectrum. So that's just my interface, though. That's basically no distortion. So now I'm plugging in my color palette with a few colors engaged, and we're just going to look at some different colors. So the first one I'm going to show you, let's pop this out to show it to you. Let's see. Okay, I know that it's not great resolution there, but this is called the 15 IPS, 15 inches per second. This is our kind of classic tape machine color. And what we're going to see is that it mimics the frequency response and the saturation of analog tape. So I'm going to go back to measure. Oops, call this 15 IPS. And I'm going to take my level, I was at dBu. We'll get into units in a little bit. So I'm going to go to 4 dBu, line level. Ooh. Okay. So this was my color palette, which has 3 colors in it, but I've only got the 15 IPS engaged. Okay, let's go back to SPL and phase, looking at 20 hertz to 20 kilohertz. So here we see the tape bump around 40, 45 hertz. So we've got a little bit, let's see, if I go up to 1K, my fundamental is at, I'm at minus 16.2 dB full scale. And then if I go up to this bump, I'm at minus 13.7. So around 2 dB of a bump. And then below that, you've got kind of this high pass filter. So that's what we would expect to see with a kind of an analog tape machine. And then when we get into distortion, I'm just gonna, oh wow, I ran it pretty hot. I'm just gonna flip back and forth. So here's just the interface again. And here's the 15 IPF, so 15 IPS. So you can see all these harmonics are much higher, much closer to the fundamental now. And where's our total? So here it gives us a plot for THD 1.55%. So that would be, I mean, subjectively, 1.55%, depends on the program material, of course, but that's, I think, right about where most people would start to notice saturation. Below that, we talk more about kind of warmth or for finish or something, but I think around 2% THD is when most people can say, oh, there's some distortion happening. So that is just the measure frequency response window, which is phenomenal. You can learn a lot about your gear just with this module of RumiQ Wizard.
Can I ask you a question about the thing that you're measuring there?
Yeah.
So that is a device that you've made to synthesize the frequency, phase, and distortion response of recording on tape at 15 IPS. Is that right?
That's correct. Yes, that's correct.
And why? And so that's used by somebody who wants to have those characteristics without recording on tape.
That's right.
Is that?
Yeah, thank you for slowing me down and asking that question. I get so excited about the software, I forgot about the hardware. Yeah, so the color format in general is intended the kind of, I just lost my power cord, but the kind of ideal person who it's suited for is someone in a small project studio who wants a lot of different tones at their fingertips without having the space for a tape machine and a bunch of rack-mounted compressors and that kind of thing.
Got it.
So that's exactly.
So
right.
they want to hear the distortion and weird stuff that happens with that format, rather than the pure tone that they have inherently in their digital pile of stuff.
That's right. That's right.
Cool.
Yeah, I could.
Like a fuzz box for a guitar.
Yes. Yeah, it's like a very, very subtle fuzz box, and kind of the nature of distortion is that when it's very subtle, it doesn't sound like distortion subjectively. It sounds like fullness or warmth, or sometimes it can even sound like clarity when you add more distortion. But we can talk more about the subjective side more if people would like, but
and that last screen that you showed with all of the distortions, some of those are happy distortions and some of those are unhappy distortions, I presume.
Yeah, we're not seeing, I mean, it gets slippery what's happy and what's unhappy, but I mean, we're not seeing any intermodular.
That's why I use those terms.
Yeah. We're not seeing any intermodular distortion in this plot, which would be kind of the least happy distortion. But
thank you. And are you able to adjust any of these, or are these a fixed?
Yeah. So some of them, the 15 IPS does not have any onboard kind of things that you adjust. The idea is you just put it in the palette, but then the palette has controls for each color, which is basically it's input, it controls an input drive and an output attenuator at the same time, so that you get more signal into each color stage and the net gain stays about the same. So you're basically, you have a saturation control more or less for each color.
Does the volume you're sending to it affect any of that at all?
Absolutely. Absolutely.
Okay.
And
In this device?
Yes.
Okay.
And yeah, we'll get more into that in the generator module, which actually that's such a good segue. I would be a fool not to take it. Let's check out the generator module, which is underneath my Zoom overlay here. Okay. So like any good test setup, this has a tone generator, which we can then send through the equipment and then monitor the output with a different module. But looking just at the tone generator, we have a lot of different modes. We can do sawtooth, square. I'm going to stick with sine wave tonight just to keep things simple. I'm going to go to 1000 Hertz, which is kind of a pretty standard test frequency. Not a whole lot to change up here. You can keep pretty much everything at the default. But one thing that RumiQ added just a few years ago, which is so game-changing for measuring analog gear, is that you can calibrate your tone generator in the computer to an absolute analog level, which before you could, so this is where things get hairy and interesting between analog and digital, because in the analog world we have some very nice standard reference levels. Line level is +4 dBu is 1.223 volts, something like that. Well, I'm not an engineer. But so now you can, if you have a multimeter, you can send a level from the from the tone generator out to a cable on your interface, and then you check it with the multimeter. How many AC volts is that? Just probing just the cable, and then you tell RumiQ Wizard here with this calibrate level box what that voltage is, and then you're calibrated. Then you finally have harmonized levels between digital and analog. And this is something that, as a maker of analog audio equipment, I deal with a lot, because all converters and audio interfaces are calibrated to different levels. And 0 dB full scale, which is what we see in digital audio workstation, has nothing to do with 0 dBu or 0 dBV or 0 dB on a VU meter. But understandably, people are very confused about that. So they'll send out something close to 0 dB full scale out to my analog equipment, and then it's clipping like crazy. And so then we have to have a little talk about analog versus digital levels. So any questions about this? I can't see if people are nodding or confused. So just a quick check-in. Was that stuff people know, or do we want to go deeper on that? Or
Let's call that good. If people aren't speaking up, let's continue.
Okay, great. So what's phenomenal about the calibration feature is that now I can actually do measurements in RumiQ Wizard in dBu. So I know exactly what voltage my analog gear is getting. So that's the generator. So basically we set our frequency, we set our level, and then we push play. And I'll be right back. My power cord fell down. Okay, so I've got my 15 IPS engaged still. I'm running this 1 kilohertz into it via the generator. Now I'm going to pull up the RTA window, which is phenomenal for looking at distortion. So I push this little record button, and now I have a plot showing, here's the fundamental at 1 kilohertz. So that's this tallest peak here. And okay, that's going to show dBFS no matter what on the side. That's all right. Oh, no, I can change it. dBu, perfect. So that's coming in. Okay, so that's our big peak, and then we see the harmonics. So this is really cool because you can see how much better visually than the other view, how the harmonics are distributed. Also, you know, if you've never really taken a deep dive on this kind of display here, it's just so satisfying to see the harmonic series laid out this way. So here we've got 1K, 2K, 3K. We've got our harmonics sitting right at the, you know, where they should be. And we've also got this great readout here, which is easy to miss. There's a show distortion button that you need to push, which shows us our THD plus noise, our noise levels, signal to noise ratio. So you know, right here, you've got all the specs for your gear, more or less. So a fun thing to do could be to double check the specs of some gear that you have, you know, wire it up, send it a signal, and then check against the manual or the manufacturer's page to see if the specs are close. That can be fun and revealing. Often specs are not, they don't tell you exactly what level they used or what frequency. So if you have to guess for line level gear, try 1 kilohertz and 4 dBu, plus 4 dBu. But this also is how we dial in. This is how we dial in the colors so that they can be fairly harmonious across the entire format. We have about 20 color modules now, and it being analog, we can't control for levels perfectly, but we try to make it so that around plus 4 dBu and at 1 kilohertz, you have around 2% THD or lower. So this is how we measure that and confirm that. So that's the RTA window. You can save out this measurement, the current or peak or both. And so once you do that, if I minimize these, you'll see it here. I can give that a name, you know, 15 IPS plus 4 dBu. Let's take a look just for fun. I'm going to keep this RTA window going. I'm going to open the generator, so that's still going. So what I'm doing right now is I just disengaged the 15 IPS. So now we see almost no distortion. Oh, let me get rid of that blue in the background there. Okay, so here's just the palette, no colors engaged. Let's try a different color. Okay, so I just engaged a different color. This is called the FA38, and this is circuitry from. I have to be very diplomatic here. This is circuitry from a vintage console from London that Bowie recorded on. It was purple, and it's called the FA38. And so as you can see at the same signal level, this one's quite a bit more subtle. But as I turn the color knob on the palette, you can see the THD creeping up and then hitting a brick wall. And there we go. So this is another cool thing to test for in a piece of equipment, is to find out where it clips. Most analog gear will behave in a similar way to this, where it's pretty clean, and then within a small range, less than 1 dB, it goes from below 1% THD to 3 or 4%, and then climbs quickly from there. So that's something that's the kind of difference that can make, for example, 2 microphone preamps. That can be the main difference between 2 microphone preamps. Most fairly well-built gear is very low distortion at nominal signal levels. But signals are not sine waves, the signals that we work with in real life. Sine waves are very predictable. There's a very controlled and small relationship between their RMS kind of average level and their peak levels. But a drum mic or an acoustic guitar is not like that. You have chaotic peaks and valleys. So in other words, you need a lot of headroom. So this can be, you can use the generator and the RTA window to really get a glimpse into the headroom of your equipment. Because a lot of stuff will sound very similar and measure very similar at nominal levels. But then once you start getting near its ceiling, the differences start to emerge. Okay, so that's the RTA window. And then a final really useful module here for Room EQ Wizard is the scope. So it basically has a built-in oscilloscope. And just push this record button here. Okay, so here's my sine wave. And let's just see what happens. I've still got this FA38 color engaged. And as I turn up the control, oh, there we hit it. Okay, so you can see the sine wave, we have some changes in level, but no major changes in the shape of it. And then once we get to this certain point where the transistors start to clip, you can see the top and bottom of the waveform clipping there. So that more or less is Room EQ Wizard. Those are the kind of 3 main modules that are really useful for analog gear. The measure one, which is frequency response, and also this distortion plot, the RTA, and the scope. So I see there's some stuff in the chat. Take a second to pause for questions before I move on.
I've actually got a question for you. As somebody who's personally destroyed a couple of your kits in my journey learning to assemble them, I guess I'm wondering, so if I am not sure whether I've correctly assembled something and I do this, is there a way that I could identify what I did wrong? Or like where I understand being able to benchmark against a spec, but then how would I actually identify how I misassembled it?
Ah, um, that's a that's a great question. That would be a really great way to spend a lifetime. Would be learning how to do that. But yeah, I wish I had like a great simple answer for that. I've thought a lot about this because education is such a big part of our mission and what we do. And I've often been frustrated myself that you really can build one of our kits without learning anything about electronics. And so you only really learn if something goes wrong. And so I would love to be able to offer people more kind of guidance around how to be self-directed troubleshooters. But I will say that 90-something% of the time with our stuff, it's a soldering issue.
Yeah.
And so we do have videos and articles and our support stuff about how to identify and fix soldering issues. And beyond that, it's usually a swapped component. Honestly, let me back up. Before soldering issues, there's test setup issues, which I'm sure is not the case in what you're talking about. But for a lot of people, interfacing analog gear with their setup is a new thing. So just that. So, but anyway, I think it looks like Rick and some other folks have raised hands, and I hope that they can give you a better answer than I did.
Or you could at least highlight the affordable price point, so it doesn't hurt to just get another and try again.
Well, also, do you know about our repair policy?
I do.
Oh, okay.
I've
Right.
used it.
Yeah, so there is a safety net. Yeah. But I'm
So
curious
people who
what.
have raised hands,
Yeah.
people who have raised hands, go ahead.
Okay, let me
Ask.
stick my 2 cents in. I make a kit also, and I sell it on the internet. It's a preamplifier that converts the venerable Radio Shack PZM into something that you can plug into a P48 mic input. And my scheme for dealing with it doesn't work is I give them a troubleshooting chart and voltages to measure and things like that. And they can always send me the chart of their voltages via email, and I'll take a look at that and do some analysis and figure out where their problem might be. But you're right. A big problem is soldering. And another big problem is getting the parts stuffed incorrectly, like getting a diode backward or something like that.
Mm-hmm. I'm sorry, I didn't see who was speaking.
Rick Chin.
Oh, okay, gotcha. Yeah, thanks for that. That is a great idea. To have them do some measurements before they contact you, so you have some stuff to go off of.
Yeah. Have you ever looked at a Heathkit manual?
Uh-huh.
You have.
Yeah.
Because
Yes,
I mean, that's kind of, to me, that's the gold standard of kit building. And their motto, their corporate motto was, "We won't let you fail."
That's great. Yeah, do you mind if I steal that idea about the measurements?
Not at all.
Great. Yeah. We have started with our bigger stuff, like the compressor, for example, which I don't know if I'm still screen sharing, but
You are, yes.
okay, let me show you that. So this is a big kit. It's a 2-channel VCA bus compressor, and I can show you in the assembly guide a bit of what it looks like. We decided this is too big to let somebody build the whole thing through without testing and then try to find issues. So at the end of each section, make this a bit smaller. So here's our kind of step-by-step guide. And then you'll see at the end of the power section, we tell you how to check the power. And then once we get into the audio, then we show you how to use exactly what I'm doing, how to use Room EQ Wizard to run a sweep and check that you've got that section right. So this alone, we just started this this is our most recent kit. We started doing this, and this has really helped a lot because then people know, where they've hit a problem, and troubleshooting becomes a lot easier.
Yeah, they're blind. They're totally blind if you don't have some way to quantitatively evaluate what's going on.
Mm-hmm.
They just kind of throw their hands up and go, ah!
Yeah. Mm-hmm.
Did someone else have some comments? Is there someone in chat, or? I'm limited by my viewing here. Anybody?
Dave Quick has his hand up.
I think Dave is putting it up by mistake, but I could be mistaken.
I have a
Dave, do you have
question.
Go ahead.
So Bob and I are asking some things about like test setups. So if we're asking if you can run it like a test sequence where there's like a pass fail limit, where you'd be able to say like, oh, like this particular thing means like this is good, or if it's failing. And then I was also wondering about if there's like a command line interface or any way to do scripting rather than having to click through the entire thing. Or if this one can't do it, if there are any alternatives that allow something like that. Because if you're looking at a production volume, doing it by hand doesn't sound fun.
Right. Yeah, that's a great question. I don't believe that any of that is built into Room EQ Wizard. For our own, we do assembly in-house for our own stuff, and for our own testing, we use another tool that I'm not going over today called RMAA, which is just a simpler interface, and it performs the same test, but it kind of you run the test and it shows you results. But we're not doing much volume either. I mean, we're kind of hand building things, so we're only building a couple things a day. So yeah, I don't have much experience with that. Those are great questions. Anybody else knows? I would love to know. But
That's still helpful. It's one more thing to track down, so I appreciate it. Thanks.
okay.
I'm curious what Bob Smith, who is our measurement expert in our section, do you have any comments, Bob? Put you on the spot here.
Yeah, when it comes to scripting, that's part of what you're really paying for when you go to Audio Precision or Prism Sound. They're something acoustics now. They've changed their name. They split off from Prism Sound. Anyway, part of what those that big expense that you're shelling out for is for scripting and extensibility, especially with the D-scope. The D-scope was meant to be a researcher's tool and allow you to go beyond. In fact, maybe I should give a presentation sometime about taking these concepts and moving them into three-dimensional measurement spaces over level, frequency, and distortions, etc. That's part of my research that I'm working on post-corporate. But yeah, the scripting and getting things to do a sequence of measurements is one of the things missing from most of these free tools. I'm a regular user of Room EQ Wizard too. We showed that years ago about that exact same thing of room acoustics. But the free tools and the low-cost tools all have limitations, and one of them is scripting.
No, thank you.
Bob, I think you're probably more familiar than I am. Isn't there a kind of like more budget D-scope in the $5,000 range now that allows you to do that kind of scripting?
Oh, absolutely. The difference is they've come out with a lower version of the D-scope, and you pay for what you want to accomplish. And there's also a software only version from Audio Precision available, and they've targeted you marrying it to the RME ADI2 Pro. That's a good combination. However, when you start looking at, well, I'd like to have this option, I'd like to have that option, by the time you get all the options added up with Audio Precision, you might as well have bought the APX 555 because they're grabbing you for, you want distortion, you want a digital interface, you want to do jitter measurements. Oh yeah, each one of those comes, but it's a la carte. And then there's the D-scope is somewhat the same, not quite as bad. And in fact, the reason I have a D-scope is because I could get that whole thing for, I think it was 12 grand, 14 grand 10 years ago, and it hasn't changed much. You get an awful lot. But you can get the software only from the APX, and then smaller versions. And then there was a company that is split off from Audio Precision, but they've gone out of business since. It was some of the people who worked at Audio Precision. I think it was called Avermetrics. Does that answer your questions?
Yeah, I was thinking of a D-scope that's kind of smaller, almost the size of a little audio interface.
Oh, that's a Quantasylum.
Oh, okay.
Quantasylum makes a dandy little device for about $500, and it won't get you the levels of distortion you can get with an ADI2. But if I was building boxes like you, I'd use the Quantasylum to get all my first round of measurements done, and then step into the bigger stuff when you really needed it. But you already have an ADI2, so you're already quite a bit there. But again, it's the scripting that you're missing, and that's where the people like Prism Sound should really know what their latest name is. It's not Prism Sound. If you go looking for Prism Sound, you will find the new name for them.
Yeah, Bob brings up a good point, which is that with this setup here, you're really constrained by the noise floor and the resolution of your audio interface. And I've invested in kind of the best 2-channel setup I could get because we're doing this professionally, but you can do this with a Focusrite 2i2 and learn a lot about your gear. You might not be able, you might not get specs that you could publish. You couldn't confidently say, oh, this is the noise floor of this certain preamp or something, but you can at least do really good comparative measurements. All right, so I'm going to move on to another tool to measure compressors. How are we doing on time in general?
Awesome.
Awesome. Okay. All right. Well, awesome is like in the 30-minute. How many minutes is awesome?
How long is a piece of string?
Let's say 20, so we
Yeah,
can eat.
you're doing fine. If you have things you want to show us, I encourage you to do that.
All right. Great. Okay. So this one is a suite of VST plugins that are free. I'm using Reaper here, but you could use whatever you want to run them. And it's called CMT. And it's made up of a test tone module, and then there are different modules for attack and release, and then there's another one here for threshold. So this is specifically for measuring things that are working in the time domain. like a compressor. So what I'm going to use to demonstrate this. Oh, Rick, go ahead and say what you want to say while I'm pulling this out here.
Oh, sorry, I'm not asking anything.
Oh, okay, got it. Maybe
Okay,
that was
lower your
Lower
hand
my
then.
hand.
Thank you.
okay. So I'm showing. How do I see myself so I can see if I'm holding this up right?
Let me
this is a
spotlight you again.
Oh, okay. This is a compressor color module. It's a simple little VCA compressor. And it has these little slide switches on it. So we can toggle between basically a light ratio and a heavy ratio, and then slow attack and release and fast attack and release. So the idea with this is that you would find a setting that you like and then put it in your palette, and then you kind of just have that at the touch of a button. In this case, your color knob would essentially be the threshold for the compressor. Okay, so I've got it set to fast attack and the light ratio. So let's do ratio first. So I just set the test tone module here to threshold and ratio. You can mess with levels and stuff, but basically it's going to step up the level. So the white line here is what the test tone is feeding, and then the blue line, it's what's coming back out of the compressor. And then at the top here, it's giving me actual numbers for the threshold and the ratio. So there's our light ratio, 2.46 to 1. And then in between tests, I just switch the ratio switch over to heavy. And now you can see we're getting more compression, and we're sitting at about 6 to 1. So this is very cool, free, very fun. Also, if you start measuring, so basically the way that I've routed this is I've got the test tone plugin, and then I've got a hardware insert plugin, which is where I'm sending to and getting back from my color palette here. And then the analysis plugin. So here I've got the threshold one. And if you start measuring your compressors, you could also just do this with a VST, a plug-in compressor in between the test tone and the threshold plugin. You're going to find some interesting stuff. You're probably going to, if you do this for a little while, you're going to have a very different relationship to the numbers printed on audio on the front panel. They're rough approximations at best. When we were, just a little anecdote, when we were doing the research for that big bus compressor you saw, we bought like 5 clones of the same console bus compressor that we were cloning. And that one has 2 to 1, 4 to 1, 8 to 1. And the ratios we measured were just all over the place. There was one, there was one where the 4 to 1 ratio was actually 13 to 1, which is like a brick wall limiter. So it's a rabbit hole. Once you go down it, you don't know who to trust besides your own ears, I guess. So anyway, you can have a lot of fun with this. And I think it can also be very instructive because if you do have a compressor and you're thinking, wow, this seems more aggressive than it should, and you check the ratio and it's 10-1 when it says 6-1, then you've confirmed that your ears are right, and you know to be a little bit more delicate with it or stuff like that. Rick, is that a new raised hand?
Yes.
All right, go ahead.
Is this software Windows or Mac? Or yes?
Yes, it's VSTs can run on Mac, right?
Yeah.
Yes.
Oh, so is it? Oh, I see. So this is a VST module.
Yes.
So it's just the plugin.
Mm-hmm.
Oh, what about
Yeah.
REW?
REW is both.
Oh, wonderful.
Yeah, it's phenomenal.
And are these plugins on Reaper?
Yeah, I'm running
on-
them on Reaper. They don't come with Reaper though.
Yeah.
Yeah. Let's see, this is called Let It Mix is the company, and this is called CMT. Maybe an enterprising person can paste it in the chat if they find it. But yeah, phenomenal tool for analyzing compressors. Okay, so now I'm going to switch the generator. Matthew Sutton, go ahead.
I was just going to point out that another place this can be really wonderful is to check the stereo tracking of two channels of a limiter. I use an audio precision for same kind of thing, but this would allow you to see if the channels are tracking together or not. And I've done some work on compressors and limiters where they were so far off it was hard to imagine, as you pointed out. So it's another really good use for this kind of a test.
That's a great point. Yeah. Yeah. All right. Okay. So attack and release. So I just have to change the mode of the tone generator here, and now I'm going to disable the threshold plugin and enable the attack and release. Okay, so I'm on fast attack here. And I'm going to go back to the lighter ratio for this test. So as you can see, I'm not sure if you clocked that. I did that pretty quickly, but when I switched, I actually just switched back the ratio, and the attack and release got longer on the slower ratio. So as tends to be the case in analog things, everything affects everything else. So here's our fast setting, 6 milliseconds attack, 33 milliseconds release. Now in our slow setting, 56 attack, 307 release. Yeah, so that's that. Let me see if I had any. Oh yeah, one thing to mention, kind of if you're planning on downloading this and trying it out, a gotcha that is not super well documented is that if you're running this on a track, it needs to have 4 channels. I'm not sure how this works in every DAW, but at least in Reaper, you can just set the track channels to 4 because the analysis plugin needs both channels coming out of the compressor, but then it also needs to be getting the kind of dry, non-compressed tones from the plugin. So if you're setting this up and it's not working, make sure you have 4 channels going in the track. Okay, any questions about this one before I move on to the last tool?
Peterson, I actually missed a question from the chat that I want to know the answer to. So backing up for a little bit, but have you used REW for characterizing microphones? And if so, how do you recommend setting that up physically?
I have not.
Okay.
Yep. I've never designed microphones. I would also love to know the answer or I'd love to hear a little bit about that from anyone in the room with experience, but I don't have any.
This is not an FFT, or is it? Because you need an FFT, I believe, comparing the dry signal to the received signal to compare microphones one to another or to characterize them.
Is your question about
This analysis tool you're using?
this one here, this compressor one here?
Or whichever one. That you wouldn't use a compressor analyzer to characterize a microphone. You would use a frequency and phase tool.
Can
Yeah,
I jump in here for a moment, Peterson?
please.
Okay, Dan, the attack release is a time domain function. He's just putting in a level, and in particular, you can put in, say, a square wave, and then watch how the compressor attacks and releases, but it's all time domain. It is not a frequency domain measurement.
Yes, which is why I was saying that to characterize a microphone, you wouldn't use this one, you would use something else.
Yeah, that
Well,
question was
the
about.
question was if you could use Room EQ Wizard, which is an FFT type, and so that's it. Problem is that it's a lot of work. I mean, you have to have a lot of pieces to be able to do that. It's probably a meeting on its own that Bob could probably lead us through very well.
You've just put your finger right on it. It's a whole meeting of its own and then some. And if we got JJ involved, it'd be 2 meetings or maybe a half-day seminar.
Yes. Okay. Question in the room here. Go ahead and grab the mic.
Yeah. So as I'm looking at the test tone generator, I see 800 or 8K. So I'm presuming that it's sending an 8K sine wave that we're testing the compressor with. Is that it?
Yes.
Okay.
Yeah, I'm setting it here, and it's a number of samples, and then my sample rate, I guess that's corresponds to 8K.
Okay. So presumably, since this is analog, whatever you set, you'll get different performance depending on what your test signal is.
Let's see. So at 4 samples, so yeah, slightly faster. So here's at 20, well, we're probably not getting clean 24K through the compressor. So let's try 12K. So that's 56 and 303. And then if I go down back to 8K. Yeah, well, very close. Let's try going a lot lower. Yeah.
A useful thing to do here would be to use pink noise bursts in addition to tone bursts.
Yeah, so the follow-up was that just going to be whether you had some recommended frequency that you tested at.
I don't. I've always just made sure I'm doing apples to apples, basically, and keeping it the same. Yeah. But I suppose it would be a best practice to keep it as high as possible without reaching the the limits of the frequency response of the gear you're measuring.
Is pink noise an option on this generator?
No, I just have, yeah.
Is there another plug-in that has pink?
What you do, Dan, is you create a pink noise burst in the signal generation part of Reaper, make yourself a track of those things, and then make the bursts for the length of time that you need, and make a number of them, and then put it on repeat, a loop, and you get it done that way.
Yeah, I'm curious if the analyzer would interpret that. But that's an interesting thing. I would like to try that out.
Well, what you do without the analyzer is you put an oscilloscope probe on there and watch the time domain response on the oscilloscope.
Yeah. Actually, we could do that. We could recreate that in Room EQ Wizard probably. With the scope feature on there.
Absolutely.
Yeah. Cool. All right. Well, I'm just going to wrap up with a rather primitive tool. It's called 4U plus blind test. And it's just a VST plugin that allows you to do blind testing. You put it on each track that you want to be able to compare. So what I have here, just for, I mean, you're not even going to be able to hear it, but just out of curiosity, what I've got here is, we're working on a mic preamp design right now. And I've got the same signal going through the same preamp, but with just two different transistors models for the amplifier, BC108 and 2N4401. And this is the kind of thing where the difference is so subtle that it's really easy to convince yourself you're hearing things if you know which one is which. We're very susceptible to that kind of thing. So I'm a huge believer in blind testing. I think it's useful. It's very useful beyond just for someone like me who's designing gear. I think if you would consider yourself new to recording or equipment, you are probably inundated by marketing and by opinions of strangers on the internet, some of which is informed and reasonable, but most of which is not. And also the way that we use words to describe the intricacies of the subjective intricacies of audio equipment is just very limiting, and it's very difficult to express the scale of the differences that you should be listening for. So I really encourage everyone, but especially if you're in that kind of newer part of your career, your journey with audio equipment, to spend time blind testing, comparing different pieces of gear blindly. And so the way that you would do that is just to record the exact same track, whatever it is. I prefer drums because I'm a drummer, because I just know how I want a hi-hat to sound, that kind of thing. But whatever it is, guitar, voice, whatever, record it really cleanly, or take a pre-recorded track and then send it through two similar pieces of gear, two mic preamps. You can always send a line level signal into a mic preamp, just turn the gain down or lower the output level, two compressors, whatever. And then put these plugins on those tracks. And then, so once you push start here, you don't know which is which. And just flip back and forth. And I like here, you can enter notes, be like, this one's woolly, this one's punchy, that kind of thing. And then see how often you get it right. It's not a test, it's not a way to make yourself feel bad about not hearing differences, but I think it's a really great way to get yourself kind of oriented and on firm ground, so that you're not, I think that most people who are new to audio tend to overestimate the differences, because it makes sense. That's how marketing works. Everybody wants to say, this thing is going to change your mixes so drastically. And differences between gear do matter, and they are real. but they're probably a lot more subtle than you're thinking. And so if you can spend some time with something like this, really intentionally listening, you can get a much better sense of what differences sound like, which ones you think matter, and also just a kind of sense of the scale of what people mean when they say a big difference between two pieces of gear, because one person's subtle is another person's extreme. So that's the final free audio tool I wanted to show you all. And I'd love to
Awesome.
hear
Thank you.
questions. Yeah.
Yeah, questions, comments. And if you would stop sharing your screen, there you go.
Mhm.
Anybody? Did somebody post links to the products in the chat?
Yes.
Tell me somebody. Okay, so if you want to save that, because that disappears once you leave the meeting. If you don't already know how to save chat, open the chat and window, and to the right of the place where you would type in a question, there's 3 dots, and click on those and there'll be save chat there. And that will save all the chat up until you start, you click that. And that will be put usually in your Zoom documents, in the documents file, at least on the Mac, in the Zoom file. So that's where you can find it. But yeah, that was really a good presentation. Thank you, Peterson.
Oh, thank you so much.
Applause.
Yeah. So this Matthew, you know, I fix things for a living, so I use some of those tools, the expensive tools, and these are new things. Some of these are new. I had never seen the yes, exactly, the compressor measurement. That's really a cool device. So thanks very much. And I'll check out more of your gear now that I know more a little bit about how it came about. But very well done. Thank you.
Peterson, are you doing anything for Black Friday? Any kind of specials coming up? Speaking of your
Oh,
gear?
wow. Yes, we are. Yeah. 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 We'll have a lot of stuff discounted for sure. Yeah. But yeah, I mean, if you've never built stuff before, we make absolute beginner stuff like DI boxes and reamp box. And then if you're really looking for a project for that weird 4 days between Christmas and New Year's, check out the bus compressor.
Could I interject one more comment here on your tools? Hornet, an Italian company, makes a thing called a Harmonics Pro VST, and it allows you to add second, third, fourth, fifth harmonics to some content that you have. During your listening training in your ABX listening training, you can add harmonic content to one track, extreme, and leave the other one alone while you learn what are differences, and then become more subtle, more subtle, more subtle in the amount of distortion that you add while you learn how to actually listen for the differences in those ABX tests.
That's phenomenal. Could you say the name of that tool one more time?
I'll put it in the chat.
Okay, thanks.
And if you just saved the chat, you'll need to save it again to pick up this comment. That seems to be the nature of that, unless they've changed it. Anything else from anybody? Here comes a question.
Oh, Bob, question for Bob Smith. Is that what type of a tool is that? Is that also a plugin or a separate piece of software, or?
It's a VST plugin and works in Reaper. The GUI is a little doji, and when you run a slider, you have to refresh the screen manually to see it. It will change the waveform graphic immediately, but the sliders, they haven't figured out how to update. It's a pretty recent development, but it's cool and be able to be something that you can apply to some complex thing, such as music, and put in a known amount of second, third, fourth, fifth harmonic distortion. And you're going to find that second harmonic, you're going to be able to add 10, 20% before you notice it. But fourth harmonic distortion, you don't need to add but just a little bit, and you're going to hear differences.
Cool, thank you. If I use it, I'll just pretend I'm working on an 8-bit processor for the graphics.
Cool. Anybody else? All right. Thanks, everybody. The room here is going to adjourn momentarily. People online, I need to look at you and see who's here. You're welcome to keep talking. And did I see Janie there? And is Jess still here? So I don't see Janie at all.
I'm here.
Okay. I'm going to make them hosts, co-hosts. There you are. And you can keep going as long as you guys are willing to chat. The ability that we have to talk to people around the world who share our same interest is really special. And I hope you'll take advantage of it while the rest of us are going to eat.
Peterson, thank you so much again and for sticking with us on so late in the evening for you.
Oh, well, thank you. Yeah, thank you all. It was really an honor to get to speak with you, and I appreciate the interest and the questions. And please feel free to contact me, Peterson at DIYRecordingequipment.com if there's anything we didn't get to. Just want to chat more about this stuff.
Great. Thank you. And thanks, Erin, for putting this together.
Sure.
Yeah, thank you, Erin.
All right. More applause here. Okay, so Janie and Jess, do you want to take it away here? Oh, we're in-person people. We're going to do a door prize thing in a second here. If you haven't filled out a sheet of, we have fabulous door prizes, including a trip, all expenses paid trip to somewhere. I'm not sure where, but go out in the hall. And Gary, do you want to get the shit, the stuff? Okay, bye everybody.